So we were talking about nested if statements. The idea behind nested if statements is that you can have an if statement that's in the body of another if statement. In technical terms, one way that programmers say that is that this code is subordinate to this if statement. So this if statement is contained, it is nested within the code block for this if statement. Are you employed? Yes. If you're a recent grad, yes. In those two cases, we could qualify for the special interest rate. If we get here, it means that we were employed, but we weren't a recent grad, so we're going to print out an error message. You must have graduated from college. And then lastly, if we didn't get through here, it's because we weren't employed at all, and so down here we just print out an error message. You must be employed to qualify. So that's an example of a nested if. The next slide cautions you to use proper indentation. Now when you're editing code and cutting and pasting and stuff like that, usually your indentation just really starts to stink. It's all, you know, messed up. And I strongly encourage you to go ahead and try to keep your indentation levels accurate. It makes it far easier to debug your code. Sometimes you can get it to format your code for you. Let me open up the project. But Visual Studio isn't as good at that as some other development environments. Okay, so I have a big app here. Say that the code was not formatted correctly. You know, say that the indentation levels were all messed up, you know, whatever, you know. People usually wind up going to the end and then tacking on a whole bunch of these just to get it to compile, you know, whatever. So you can highlight it all, Control A or whatever, and then come up under Edit, Advanced, Format Selection, or Format Document. And if it works, it'll fix all the indentation level errors. So somewhere up here I had poorly indented the code, like this question, do you have spare money? Say that was unindented, and then this one was, you know, indented too many times, and then we had put a brace there and a brace there, and it was just really starting to look awful. Highlight the code that you care about, or all of it. Choose Edit, and then Advanced. Format Document, and it fixes that. It may not be perfect, but it's certainly a lot better than it was. And what I mean by not perfect is the fact that I had moved the braces up to the same line. Well, that's considered a valid formatting technique. That's called the Kernighan-Ritchie style of comment blocks, where you put the brace on the same line as the code, you know, that precedes it. Some people think that, well, one reason that's advantageous is you just simply puts more code on the screen at the same time. So if I was typing in a big sample for y'all, I might be tempted to do that. But I really like the looks of it better when the braces are on their own lines. But a lot of editors, a lot of programming tools default to doing it this way. You'll see both. Just pick one and go with it. You can always annoy your coworkers by going into their code and changing all their braces to the opposite style. So the if-else-if statement. If-else-if tests a series of conditions until one is found to be true. We did that. If grade is greater than 90, print A. Else, if grade is greater than 80, print B. Else, if grade is greater than 70, print C. It's often simpler than using nested if-else statements. And what does that mean? Well, we could format this code like this. And it doesn't add clarity to the code to do it this way. There's absolutely no advantage to doing it this way. Let me finish. Let me get this going a little bit more. Oh, I should be actually doing this in the code editor. It's going to be, forgive me. There we go. Then I have to add enough closing braces so that it'll actually compile. Who knows if I've done that successfully. Anyways, if you look at the way I've structured the code, this is that same ABCDEF program, written with ifs and elses, but not if-elses. If grade is greater than 80, do that. Else, okay, well now we have a code block. If grade is greater than 70, do that. Else, oh well, now we have a new code block. If grade is greater than 60, print out D. Else, print out F. That's valid code. There's always more than one way to write a piece of program or to write a series of comparisons or logic. But we have that, but it looks really tacky. We can do far better by making it just look like I was showing you before, using else ifs. So hopefully you think that looks better, because if you disagree, you're completely wrong. No, I'm kidding. But if we compare the two, we have this as opposed to this. Which looks better to you? Not to prejudice you, but this looks like vomit. Okay, y'all aren't laughing at my jokes tonight. I'm sorry. So if else ifs allow you to get away from using a series of nested if statements. The logic for these is absolutely identical, but this is much cleaner, much easier to maintain and modify. If it is raining, take an umbrella. Else, if it is windy, take a hat. Else, take sunglasses. If expression, do statement 1. Else, if another expression, do statement 2, or a block. Else if expression, do another block of code. Now if you're going to do a block of code, you better be putting braces in there. You can't put more than one line of code in there after an else if and expect it to magically work. If I went in here, into my code here, and I did this, if grade is greater than 90, see out that, and then I said, congrats, that's really good. That's not going to work. All of a sudden, all these, you're raising your hand?
I was just wondering if you had to have an else, or if you could have the last one also be an else if.
Well, the last one can't be an else. Well, yeah, the last one can be an else if you're just not putting a condition down at the bottom. That would have. This is called a catch-all. You know, if you put something down here at the bottom. If none of the others are true, then that happens. And if you don't think that's necessary, you can leave it out. So why did all of a sudden all these else statements light up as showing as errors just because I added this line of code? Yeah, because the way this stuff works is that if you don't have a code block defined with a brace, then only the next line of code is considered as part of that if statement. So this is the only line of code that is subordinate to that if statement. So this next one actually looks like that. How could you do an else after a cout statement? That doesn't make any sense whatsoever. So if you're going to have multiple lines in a code block that are executed by an if, use braces. And it's not a bad idea just to put braces there even if it's a single line of code. It just takes up more space. You know. That way if somebody comes in and modifies your code, you know, they're not going to mess up and forget to add the braces themselves. Why don't I do that up here or when I'm giving you code examples? Well, sometimes I will, but it just takes up more space, meaning it's harder for y'all to type in after me. You know, I have to scroll up and down to show you the code and all that. But this would be a more proper way of doing that. The trailing else clause is optional, but you can catch errors with it. If your test score is greater than the A score, you print A. Else if test score is greater than B, you print B. Else if your test score is greater than 0, you print F. Else you print invalid test score. So if they actually have a negative score, then some calculation has gone enormously wrong. And so that's why you may put a final else statement after a series of else ifs. Not strictly necessary. Flags. flag is a variable that signals a condition. Keep running, you know. You're programming a thermostat, you know. Heater on could be a flag. As long as the heater is on, that variable would be set to true. It's usually implemented as a Boolean variable because it's a condition that's either true or false. But you can also use an integer where the value 0 is usually considered false and a non-zero value is considered true. This is like more common to old C programmers before the invention of the Boolean variable type. As with all other variables, it has to be assigned an initial value. So what would be an example of something like that? You write a little loop that's going to do some data entry. Boolean, keep running is equal to true. And then while keep running, do some code. But if something happens, if the user decides to quit, you could set that flag to false. For some reason, Alex Jones and his false flag accusations runs to my mind. And anyways, so then if this flag is ever set to false, it will exit the while loop. That's the idea behind a flag, is that it is a variable that indicates the state of something, and it should be a true-false state. And as long as it is set to true, one thing will happen, and if it is set to false, another thing will happen. Now, is the fact that it's a flag mean it's defined differently? Do you have to do that? Do you have to call your variable flag? No. It's just a variable that you're, you have set its meaning. Excuse me. No leaving. So you might have a game over flag. Then in your code, you know, if game over, display insert coin. Whatever you're supposed to do when the game is over. Yeah. That's a flag. It's a state that the program can act upon. They don't give an example. Whew, we'll just fly past that, huh? Logical operators. We've talked about these before, right? Ands and ors and nots. If you use an and, both sides of the expression have to be true. If you use an or, it's either one or the other. And not reverses the truthiness of it. So you could do this. If, let's set up a temperature. Temperature is equal to 36. If temperature is greater than or equal to 32 and temperature is less than or equal to 212, we could see out water is a liquid. So there we go. We've used an and. For this message to be displayed, the temperature has to be greater than 32 and the temperature has to be less than 212, the boiling point and the freezing point of water. Or we could use an or statement. Come up with a reason to use an or statement. If the temperature is less than 32 or the temperature is greater than 212, see out water is not a liquid. Kind of the reverse logic. There's actually a law, a mathematical law, that says if you reverse the logic of a statement, you have to switch the ands to the ors. But so this one checks to see if it's inside a specific range. If it's greater than 32 and it's less than 212, both of these have to be true before the see out works. Here we're using an or. So if the temperature is less than 32, if it's freezing, or if the temperature is greater than 212, it's boiling, we will print water is not a liquid. That pretty much fundamentally defines right there the difference between an and an or. And then not just reverses it. If you put an exclamation mark, then whatever is behind it turns into the opposite value. So I could write it like this. If not temperature greater than 32 or temperature is less than 32, water is a liquid. Now that's kind of silly considering that we were able to do that with that line of code. This code is more complex, but logically they do the same thing. We can give better examples than that though. Like if not game over, you know, then print, you know, wow, aren't we having fun? So if game over is true, it's not going to print this. Why? I did start the recorder, didn't I? Please tell me yay. Okay. All right, so game over is equal to true. If this expression, then print cout is equal to fun, or display fun. So what is game over at this point? Ignoring anything in front of it, what is the value of the game over variable? It's true. So what is not game over? So yeah, so this would say if false, print out fun. Are we going to print out fun? The question hangs pregnant in the air. No one's listening. What has to happen before this works? The if statement has to be true. So if you see something that says if false, do something, that would just flat out be wrong. You know. So doing this, if not game over, is the same as wording it like this. If game over is equal to false. Which do I prefer? I like that one. To me, nots make the logic of the expression more difficult to read. If I saw this, I would want to rewrite it so that it didn't use the not and the parentheses. You know? And I would do that by taking that out and then changing the ors to ands, and you know, and then it would work. Similarly, if not game over, that is pretty clear. But to me, this is even more clear. If game over is equal to false. So game over is equal to true. We get down here. If game over is equal to false. Well, it's equal to true. So are we going to execute our statement here? Yeah. Did I hear a no? Yeah. All right. Heard one no. So we would not print fun. Same case here. Game over is equal to true. If not game over, print fun. Unfortunately, the game is over, so we're not going to print fun. So this takes that value, which is true, reverses it, and then since whatever's in the parentheses is false, it doesn't execute the body of the if.
So in that second if statement, if I was to just put equals true, then it would still be comparing it to game over somehow? Question mark?
Yeah, you could do.
Like if in the parameters I just put equals true. Like if that's all I wrote in this parentheses.
Well, that's not going to work because it wants two operands.
Oh, okay, but if I put equals false, it would just be there but never run. It wouldn't throw an error.
Well, if you did false is equal to false. If you do equals false, it still wants another operand on the other side of the equal signs.
Oh, okay, cool. Sorry, I misunderstood.
No problem.
You said. That's good.
So, logical operators, examples. All right, there was a marker here at 1 o'clock. There is not now. There's a marker thief.
Must be the professor in the class before you. He's the lawyer.
Brandon. What's all this stuff? Hey, if you ever need a TI-30 or a Toshiba remote or a empty glass case. However, none of those are marked. Well, that's going to make it pretty difficult for me to write stuff up here, but let's do it anyways. Okay, here's our expression. X greater than Y, and I need to as usual, shift this off to the side so that we can't actually see the answers. Okay. Okay. Here's the expression. It might be something like if, and in parentheses and all this, and we would decide whether it's going to execute the body of the if statement or not. X greater than y. Is that true or false?
True.
X is 12, y is 5. That is indeed true. And that means both of these are going to have to be true. We've already validated that this one is true, so now let's check this one. Is y greater than z?
Yes.
Yeah, it is. So both of these are true, so the value of the entire expression is true. So if we had if this print yippee, it would print yippee. All right, here's another one with and. Both of these have to be true before we would enter the if statement or whatever. Both of them have to be true for the expression to be true. Is x greater than y?
Yes.
And is z greater than y?
No.
No, this is false. And since this is an and, both sides, both operands have to be true. So since this is false, it renders the whole expression false, and if we had an if this print yippee, it would not print yippee. All right, let's check this one. Now we have an or. So if either side is true, either one or the other, or both, then it'll work. Is x less than z?
No.
No, it's not, but we still have a second chance. Is y equal to z?
No.
No. So both sides of that were false. That means that the result would be false. It evaluates to false. Is x less than or equal to z?
No.
No, 12 is not less than -4, so this is false. But we have a second chance because it's an or. Is y greater than or equal to, is y not equal to z?
Yes.
That is true because they're not the same. So this part is true, which means the whole expression is true. And then lastly, well, there's a sneaky little knot up here in the front, but we're going to ignore that at first because you have to do PIM-dash, you have to do parentheses first. Is x greater than z?
Yes.
X is indeed greater than z, 12 is greater than -4, but then this turns it to a false. So this was true, now it's false. So if you had if that, then print wow, it's not going to print wow because this expression is false. I think we got those right. Here is that lone program rewritten to use the and. Wait, I wrote that. That means I have the marker. I'm a kleptomaniac, apparently. Really? Somebody stole it when I got to get a drink of water. I'll blame it on y'all. Okay, so you have one? Well, I'm not going to write with it now, but I'll remember that. Thank you. Okay, so here's the same logic. You have to either be employed and a recent graduate to qualify for the special interest rate. So rather than use nested ifs like they did earlier, if employed is equal to yes and recent grad is equal to yes, print you qualify. Else say sorry, go do something else. So if you're using nested ifs, quite often you can replace the logic with an and sign. And I'll kind of show you what I mean, using the same idea. If temperature is greater than 32 and temperature is less than 212, print water is a liquid. This could have been written like this. If temperature is greater than or equal to 32, if temperature is less than or equal to 212, print, or see out, water is a liquid. These two chunks of code perform the exact same way. This one is just written as a nested if statement, and this is written with an and operator, and logical operator. Why do they work the same? Because for this to happen, this one has to be true, and this one has to be true. Because if this one isn't true, we won't enter the block at all. If this one's true, we'll get to here, but we'll fail this check, and we won't print that. So if you have nested ifs, then perhaps you can rewrite it so that you use an and to clear up the logic. And if the temperature is greater than 32 and the temperature is less than 212, print this out. So that's how we worded it down here. Or statements, like this one, you don't necessarily do that based on nested ifs, but on sequential ifs. This could have been written like this. If temperature is less than 32, then C out. I'm just going to copy this line. Else, if temperature is greater than 212, C out that. And again, these are equivalent. Sequential ifs, if-elses, you can sometimes replace that logic with an or statement. If the temperature is, if you're performing the same code under both of them. We're going to print out water is not a liquid if the temperature is less than 32 or if the temperature is greater than 212. So since we have two if statements that produce the same results, we can combine those with an or. And the reason that works is if this is true, it would print it out. But if this was false, it's still going to come down here and do that second check. And if that one's true, it's going to print it out. So that is the essential or logic, if either one of these or both of them are true. The only, yeah, I was going to babble a little bit more, but that's good enough. All right. In terms of precedence, exclamation mark has the highest precedence, followed by ands, and then ors. I'm going to see if I can justify why that might be true. And I would like to borrow your pen. Alrighty, so you can create what's known as a truth table. And a truth table is when you have two inputs and you're either anding them together or you're oring them together, and you're going to see what the result is. So false, 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 true, true, false, true, true. We're using and. So we're doing this, A and, excuse me, need to do those ampersands, B. Like if A, B, then set the result to true. If these are both false, are we going to do whatever's in here?
Yes.
No, because this is an and for an and, both of these have to be true. So if A is false and B is false, we will not do our print or whatever. So that's a false. What if you have a false and a true? If you have A and B, and if A is false but B is true, are you going to print out whatever's down here?
No.
No. What about A instead of false, true, true, false? What if this was true and this one was false?
No.
Again, that's not going to work. What if they were both true?
Yes.
Yeah, then we would print out whatever. So all of these, all the results of the A and B are false except for that one, when they're both on, when they're both true. You could rewrite that with zeros. We could do another truth table with or. False, 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 true, true, false, true, true. So if your statement looked like this, if A or B, print out something. If A is false, B is false, are we going to print it out?
No.
Everybody agree?
Yes.
Good, because that's correct. Or means one or the other one or both has to be true. If they're both false, then the result is false. What if A was false but B was true?
Yes.
We will print it out. Same as if A was true and B is false. Same as if they were both true. So notice that we have 3 true conditions here, and we have only 1 true condition on the AND side. Taking this idea just a little bit further, what if we replace the trues and the falses with zeros and ones? Zero and 0 is a 0. 0 and 1 is a 0. 1 and 0 is a 0. 1 and a 1 is a 1. Now this is in binary circuit design or whatever. You know, you have AND gates and you have OR gates, and they both, you know, they draw it something like this. That's the wrong shape, but both of them have to be on for the signal to be transmitted. So I hope you can see, you know, that if you replace F's with zeros and T's with ones, then this is what your truth table looks like. Let's do the same thing over here. And with A and B using zeros and ones.
This is OR.
Thank you. Or truth table with OR, A, B, and result. So we could have 0, 0, we could have 0, 1, we could have 1, 0, or 1, 1. 0 or 0 is a false. 0 or 1 is a 1. What about a 1 or a 0?
1.
And what about a 1 or a 1?
1.
Okay. Take a look at this and pretend that instead of a AND sign, these were multiplication. What is 0 times 0?
0.
What is 0 times 1?
0.
Yeah, what's 1 times 0?
0.
And what's 1 times 1?
1.
So, AND can be considered a logical version of multiplication, or can be considered a logical version of addition if you only have 2 states, on or off. 0 plus 0, what's that?
0.
Right, so what's 0 plus 1?
1.
What's 1 plus 0?
1.
And what's 1 plus 1? I know you're going to say 2, but our only 2 possible states are 0 and 1. So 1 plus 1,
1, 0.
on plus on is a 1. So we could treat ORs like they're pluses. And if you were taking a logic class, you would actually write them that way. You would say, if A plus B, and when you were reading it, you would say if A or B. Now, why didn't they use a plus sign in the programming languages, since centuries of logisticians had used a plus sign to mean OR? Well, plus sign meant something very different in computer programming. So, hope that's clear. Anyways, I hope that kind of burned in the difference between AND and OR. That's the real reason that I went on so long about it. Also kind of wanted you to see the similarity between AND and multiplication and OR and addition. And what do we know from index? Which gets done first, multiplications or addition?
Multiplication.
Multiplication. So that is saying that the AND operation has higher precedence than the OR operation. So if we did this, if A and B or C and D, if we pretend that these are multiplication and these are addition, what's going to get done first out of that string? That will get done first, then that will get done, and then finally we will check the OR. And y'all do realize that these letters are just shortcuts for some evaluation. You know, it could be if T is equal to 0 and game over is equal to false, you know. Or T is equal to 1 and game over is equal to true. Whatever, you know. Same idea. You would have to parse it the same way. We'd look up the ands and we'd do them first. So let's say that t is equal to 1 and game over is equal to false. Let's decide whether this entire statement evaluates to true or false. Somebody blurt out an answer and we'll decide if you're right or wrong.
False.
Who else agrees? More than one person has to be able to do it in their head. I'm going to lock the door until somebody else gives me an answer. Just take a guess. All right, is this going to print wow or not?
No.
It's not going to print wow. And why is that? We're going to do the ands before we do the ors. So, is t equal to 0?
No.
No, that's not true. So we can even skip the rest of this evaluation. We don't need to check the value game over. And by the way, that's known as short circuiting. If the first part of an and is false, there's no reason to even continue. So we know that this side is false. Then, well, there's an or here, but that's not the highest precedence. We have another and here. Is t equal to 1?
Yes.
Yeah, it is. Is game over equal to true?
No. No.
Okay, so this expression is false. So false or false is equal to
False.
false. So this if statement is false, we would not print out wow. That's how you use the precedence. The not sign has the highest precedence of all. We could reword this game over is equal to false by taking out this equals false and just putting the not in front of it. And we could reword this game over is equal to true because that is the same as that. You know, that's a Boolean variable, so you don't have to compare it to true. You can just say if that. So in the order of precedence, you do nots first, then you do ands, and then you do ors. Now in this case, we would still skip evaluating that, but we can't skip evaluating it because we have to do it first because of precedence. So we would look through here. Not game over. Well, game over is equal to false. So what is not game over?
True.
That's true. But unfortunately, t is equal to 0, so this is still going to be false on this side. I don't know if short-circuiting means that because of that not, it would evaluate that first or not. I kind of have a question about that. So short-circuiting takes two cases. If you do this, if A and B, if A is false, there's no reason to evaluate B. So if this is something like temperature is less than 32 and temperature is greater than negative 100, whatever silly range we're doing, if this one is false, we're not going to even check this one. That's not short circuiting. That usually doesn't matter. In some certain cases, it could matter. OR statements can also short circuit, but they work the other way. If the first part of an OR statement is true, you know the whole thing is true. If temperature is greater than 32 and temperature, excuse me, we're using or temperature is less than 0, whatever. If temperature is greater than 32, we don't even need to check this second one. So ands short circuit if the first operand, the first clause is false. Ors short circuit if the first operand is true. Short circuit makes it sound bad. Ooh, it's dangerous. It's not. It just means that it's skipping part of it. If this is an and, then if this part is false, it doesn't check this. It already knows. So for efficiency's sake, in order to run as fast as possible, it doesn't do this evaluation. Why is that important? Well, this might actually be a function call. It may call a function that's 1,000 lines of code long. You know, you don't want to necessarily invoke that 1,000-line function if you can rule it out with this. Same here. If this is true, then we're not going to do this second one. And that may save considerable time if the second expression was actually a function call. You know, a function can return a true or false just as well as anything else. Or, you know, what if this was like, if get temperature is greater than 32 or get temperature is less than 0. And what if get temperature actually had to query the state of a thermometer? It had to read the thermometer. So it might take a whole millisecond to do that, and we're used to, you know, being able to execute 1,000 statements in a millisecond. If this is true, then there's no reason to call get temperature again. Now this is just sloppy programming, really. We should, put the result of get temperature in a variable and then base it on that. But that's just an illustration of why short circuiting is important. You can conceivably save a lot of programming time, not programming time, execution time, by wording it so that if this clause is false or true or whatever, then it won't do the second one. Did they have to do it that way? No. They could have made it. The programmers of the designers of the language could have made it so that both sides of the operator were evaluated no matter what. And that was just a decision they made when inventing the C language, and most other languages that I know of have followed in their footsteps. So if the value of an expression can be determined just by evaluating the sub-expression, here they're calling it a sub-expression, on the left side of the logical operator, then the sub-expression on the right side will not be evaluated. So this is a sub-expression here. If that one is false, there's no reason to run this one, since it's using and. If this one is true, then there's no reason to run that one. So, there, learned a new term, sub-expression. We were calling them operands earlier, but I guess since these operands are entire expressions, that makes sense to call them that. Checking numeric ranges with logical operators. You can use AND to check to see if a value falls inside a range. If your grade is greater than 0 and your grade is less than or equal to 100, print valid grade. But you can also test to see if a value falls outside a range. If you're checking to see if it's outside a range, you use OR rather than AND. And I did that in my thing when I said whether it was liquid or not. So somewhere up here, here we go. I was checking to see if it was outside the range of liquid. 32 and 212. We may be stopping real soon. So since I was checking to see if it fell outside the range, I used an OR. Here I'm checking to see if it's within a range to determine if it's at temperature in which water is a liquid state. I used AND. All right. I fear that I'm going to start gagging and make all y'all uncomfortable. So let's go look at the next assignment. And like I said, I'm going to add 2 days to its due date. This one is called telephone digit to letter. The inside of it may have a slightly different name when we actually open the document. Okay, here's the idea. Problem description, telephone conversion software. Now you remember back in the old days, Katharine Hepburn would tell Spencer Tracy, call me at, RE32541. And they gave the first 2 letters of the phone number as letters. Why? Who knows why? I know that Midwest City's letters were RE because this was called a regent area. That was the name of our prefix, was regent. So R is a 7. E is a 3, so if you were going to call my old home number, which was 737-4978, then you would say RE7-4978. Now, to me, that makes absolutely no sense, and apparently to everyone else it made absolutely no sense as to do it that way anyway, so nobody does that anymore. Nobody uses, 2 letters followed by a series of numbers. However, you see things like, for a good time, call 1-800-HOT C++. You don't like that. So here you have to do the same thing. You have to figure out what an H is. An H is a 4. And then, well, this is really ambiguous, isn't it? Is that O a 0 or is it an O? But anyways, H is a 4, O is a 6, T is an 8. C is a 2. Don't you remember the good old days of when you would text and you'd have to press, you wanted to use S, which is a very common letter, so you'd press the 7 key 4 times just to type in a single S. Yeah. So, good times. Anyways, what we're going to do is we're going to write a program that if you give it a letter, it prints out the numeric equivalent. And that's really all I need to say about it. But if you type in an A, it's supposed to print out a 2. If you type in a Z, it's supposed to print out a 9. If you type in a Y, it's supposed to print out a 9. It doesn't need to do anything more complicated than that. We could make it so that it would process an entire string, so it would convert, hot C plus into, the equivalent numbers. But this first version of it just asks for one letter, and the result is going to be printing out one number. So your task is to design, code, and test a Visual Basic program. Forget that it says Visual Basic. I obviously need to change this. Ew. C++ programmer. Where the user will enter a alphabet character, A to Z, and the program will return will print a corresponding number or digit. The user should be able to enter either a lowercase or uppercase letter. So the way the program is supposed to work, ask the user for the letter, convert it to uppercase just to make your comparisons easier, and then print the corresponding digit. If they didn't type in a digit, you're supposed to print out a not a digit message. Excuse me, if they didn't type in a letter, like what if they type in an exclamation mark? Well, modern keyboard, in testing, one of these was an exclamation mark. But really, if it's an exclamation mark or a minus sign or whatever, we want to print out an error message that says not a digit. So to make it easier to process the input, you should convert your data to an uppercase letter. So here's an example, just to start with. And once you use this as a starting point, the rest of the program becomes very easy. This is like a 20-minute assignment if you get the idea of it and you use this starting code. But the way it works is we define a character, we ask them to enter a character, we let them type it in with CIN, we convert that character to uppercase. We haven't necessarily seen this function before, but I'm telling you that 2 upper will take whatever character is stored in there and turn it uppercase. So if they type in a lowercase a, it's now uppercase. Then we have an if statement. If the character is an A, or the character is a B, or the character is a C, we will print out the letter, whatever, corresponds to the digit 2 on the telephone keypad. And then you're going to have an else statement. And after that, you're going to check to see if it's D, E, or F. And then after that, you're going to check to see if it's G, H, or I. Here is the same program using strings rather than characters. We hadn't really used the character data type. A character can only hold one keystroke, whereas a string can hold multiple keystrokes. However, in this case, we're going to be assuming that it's only got one. Yes, sir?
That 2 lower up there on the top right of your screen, should that be 2 upper to change it to uppercase instead of lowercase?
Really?
In this one, go down.
Wait, do I have 2 lower anywhere?
You have 2 upper right there. You have 2 lower down in the string version.
The function
Title
title
to
to uppercase.
Yeah, right there on the end of your transform.
Yeah, that's moronic. Thanks for catching that. Several mistakes for me to correct. That's one of them. Very good catch. Anyways, here's the same code, exact same code, except it uses a function that we write here to turn that letter into uppercase, or in this case, lowercase. I will post a corrected version of this. Logic. If you like flowcharts, and who doesn't, here's what it could be. Alrighty. So that's really, since I gave you the starting point code, a pretty easy assignment.
When does it due?
1 week from Wednesday, or Tuesday night, a week from tomorrow, actually. So I'll find out the answer about getting y'all's software to not say that it's expired, and see y'all on Wednesday.
Use or download a crack and infect your computer with viruses.
That's right. Get on Pirate Bay and download the one that says Free Visual Studio, parentheses, no viruses.
We know you've been looking at illegal porn. Give the FBI $300 or else we will prosecute you. everybody knows